Today we read some more things on Boolean function minimization. If I quickly summarize the portion that already we have read in reducing the expression using K-map, that if we draw one K-map for a given expression, then first we see the adjacency of ones present in the K-map. Then we try to form the couple, means 2 adjacent ones, quad 4 adjacent one, octuplet the 8 adjacent one, or a hex box means which contains a 16 adjacent one. And always we will try to form a largest group, because largest group always achieves maximum reduction. We have seen last day 1-2 variable function depend if we apply the rule of reduction. Then this is one example, that Z is a b bar plus a bar b bar. Then what we have seen, that there are 3 min terms. So, there will be 3 ones in the K-map. So, the first couple will be the first column, as well as another couple is the second row. So, the first couple will be a bar b bar, because that first column represents that thing, that a bar b bar plus a b bar, and that will be nothing but b bar, which represents the first column, that b bar. Similarly, the second couple is the nothing but second row a. So, this is reduced to a plus b bar. Last day we have seen that thing. Now, today we see how this rule is applicable for 3 variable function. Again we take one 3 variable function. Now, the function is that a bar b c plus a bar b c bar plus a b bar c bar plus a b bar c. Now, if we draw the Carnot map, see here there will be 2 rows and 4 columns, because it is a 3 variable. So, it has 2 to the power 3 means 8 min terms. Now, in these, out of these 8 min terms, there are only 4 min terms present in this particular function. What are these 4 min terms? So, one is a bar b c. So, in the table this is a bar and this is b c. So, this is 1. So, this is 1 a bar b c. Now, a bar b c bar, see a bar b c bar. So, this is another min term. Then a b bar c bar, a b bar c bar means the third min term. Fourth min term is a b bar c. So, this is another min term. Now, if we try to find out the couples or quads, you see here only 2 couples exist. So, this is one couple, this is one couple, and this is another couple. Now, if we just see how the first couple reduces, because the first couple, for the first couple the row represents the literal a complement, means a dash, and the 2 columns are b c and b c bar. See, c and c bar are the complemented as well as uncomplemented one exist, but b is fixed. So, the thing will be a bar b, or in other way, if I draw or if I write the min terms of the first couple, this will be a bar b c, this is one min term a bar b c, and the second couple this is a bar b c, a bar b c bar. Then if I from these two, if I take a bar b common, a bar b, so from here if I take a bar b common, then c plus c bar and C plus C bar is nothing but 0. So, this will be A bar B. Similarly, the other couple this becomes, and that A B bar C bar, A B bar C bar and A B bar C. So, if we take the second couple, this becomes from here, if we take common the A B bar, then it will be C plus C bar and this will equal to A B bar. So, I get A bar B plus A B bar. Now, from here also I can directly tell, from the Carnot map I can directly tell that this will be, this 4 terms will be reduced to these 2 main terms, because the first couple reduces to the A complement as B is fixed. So, A bar B. For the second couple, the second row represents the literal A, and for the first 2 columns, see, this is 0 0 and 0 1 means that B bar is fixed. B bar is fixed for the first 2 columns, whereas C exists both in complemented and uncomplemented form. So, it will nullify. So, from the first 2 columns, B bar will be there, and for the second row it will be A. So, it will reduce to A B bar. So, in that way we can directly tell that it will be A B bar. Now, we take another 3 variable function, that A bar B bar C plus A B bar C bar plus A B bar C plus A B C bar plus A B C. Now, if we, here there are 1, 2, 3, 4, 5 min terms. So, 5 min terms we put in the K map, and the 5 min terms will be, so this is my A bar B bar C, this is my A B C bar, A B bar C, A B C, A B C bar. Now, see, here we are getting one, here we are getting one quad. So, this is one quad, and we are getting another couple, this is one couple. So, this is one. So, in this K map one couple exists and one quad exists. So, what will be the quad reduces to? That, see, the quad will be the second row. So, second row means these 4 min terms. So, from here if I take the first, we notice that each of the min term contains A, the literal A. So, I take A common, then it will be, the term will be A, then B bar C, then B bar C bar, B C bar, B C. Now, see, from the inner expression, if we consider the first 2 min terms, then that B bar is common, and then we take C plus C bar. Similarly, from the last 2 min terms, B is common. So, this will be C bar plus C. Now, C plus C bar is 0. So, A B bar plus B, and again B plus B bar is 0. So, the quad reduces to A. Now, see that from the map itself I can easily tell that this quad means A, because see that B bar C bar, B bar C, B C, B C bar. So, all the complemented and uncomplemented of the 2 literals B and C exist in the quad. So, they will nullify. So, simply that for the second row of the literal, that means A, that will be the result. So, this quad reduces to A. Now, here from the couple, that it will be only, because it is the second column, that means A bar and A will nullify. So, only the column, that means B bar C, the min term B bar C will be the min terms for the couple. And now, we see if we reduce that thing, whether it comes or not. See, that the couple that A bar B bar C and A B bar C. So, from there B bar C is common and A plus A bar, and that means that B bar C. So, which is nothing but the column, the second column. So, Z is the quad reduction of quad A and the reduction of couple B bar C. So, this will be A plus B bar C. So, now we see the last is answers of the quiz. The three questions we have given, and mainly that is the simplification of the Boolean function. Now, this is all the three questions are nothing but the 3 variable function reduction. So, just now we have discussed the same way. If we see the first one is the A B plus A B bar C bar plus A bar B bar C bar. Now, one thing we notice here, see that here this is a 3 variable function, but the first min term A B, here one literal is absent. Now, if I introduce the literal which is absent there, that means A B becomes, A B is A B into C plus C bar, means this becomes A B C plus A B C bar. So, that is why now these 3 variable function where 3 min terms are there, now it has been extended to 4 min terms, that means A B C plus A B C bar plus A B bar C bar plus A bar B bar C bar. Now, see, this is actually initially we are not reducing, rather we are extending that thing, but this will help, as already we have discussed, this will help the drawing of K-map or just putting the ones in K-map. So, now we can easily put the 4 ones. So, this will be the ABC, this is my ABC. So, this one is for ABC. Now, ABC bar, this one is for ABC bar. Now, this is for A B bar C bar, and only one is left, A bar B bar C bar. So, these are the 4 terms. Now, if we draw the couple, what will be the thing? If we draw the couple, then this is one couple identified and this is another couple identified. So, what will be the, from the K-map itself, the first column represent B bar C bar, and so this is B bar C bar for the first column, and the other couple is the C, the second row it will be A, and BC and BC bar means only B. So, that will be AB. Now, just notice that according to the rule there can be another couple. See, this can be, say if I take this one and this one, then this can be another couple. But see, this one is already included in this couple and this one is already included in this couple. So, we have just ignored this thing and it is giving that a reduced form. Later again we will consider this thing in details. So, the second example on the second question of the quiz, this was a 3 variable function and here it was the function is given this. So, again the same way, because here all the min terms consist the 3 variables. So, immediately we will give the ones for each min term and we will try to find out the couple. Now, see here that the couples are, this is one couple, this is one couple, and see this one is again left. So, we will put that this is and this one. So, there will be three min terms, reduced terms, but again for the 3 variable it will all reduce to 2 variable. And similarly, we can the third one is also we can do in that way. Now, already we have seen the 3 variable, that 3 variable function. Now, we see that how they work for the 4 variable function. Now, first we see one 4 variable function. See, the 4 variables are a, b, c, d, and this is one function given that f is a, b, c, d plus a, b bar c, d, a, b bar c bar d plus a bar b c d, a bar b c bar d bar, a bar b bar c d, and a bar b c d bar. Now, as here that it is a 4 variable, so number of min terms will be for 4 variable functions, the number of min terms is 2 to the power 4, 2 to the power 4 equal to 16. So, the K-map size will be 4 by 4 means 16, and we divide this as if column we are giving a, b, these 2 variables, and the or rows we are giving a, b, and columns we are giving c, d. That can be vice versa also. So, for this particular example we have taken a, b or c, d. This can be c, d, this can be a, b, but for this example we have taken this. So, for all possible combinations of a, b, that will be a bar, b bar, a bar b, a, b and a, b bar, means these are we can write in different way also. This can be 0 0, 0 1, 1 1 or 1 0. Similarly, this c, d value can be 0 0, 0 1, 1 1, 1 0. So, now for all the min terms, because these are the 7 min terms exist in the function f. So, we put 1. So, for a, b, c, d, now one by one we see that how we are giving. So, a, b, c, d, so this is a, b, the third row and third column, means this is my term, a, b, c, d. See a, b dash, c, d, so a, b dash means 4th row and c, d is the 3rd column. Now, a, b dash, c dash, d, again it is the a, b dash means the 4th row and c dash, d is the 2nd column. So, this will be the thing. Then a dash, b, c, d, so it is the 2nd column and the 3rd or 2nd row and 3rd column. Now, a dash, b, c dash, d dash. So, for a dash, b, this is the 2nd row, it represents 2nd row, and c dash, d dash means the 1st column. So, this is the 5th min term, and a dash, b dash, c, d means a dash, b dash is the 1st row and c, d is the 3rd column, a dash, b, c, d dash. So, a dash, b is my 2nd row and c, d dash is the 4th column. So, all the min terms are included. Now, we try to find out the couple or the quad. Now, first we are seeing there exists one quad here. This is one quad. Now, see here there is another couple and another couple. I can, if I fold, I can put this is, and these are one couple. So, two couples and one quad exist in the 4 variable function given. Now, we see that okay. So, what will be the quad if I, this is my, see this is from the K map, the quad will be simply the CD, because that all the 4 columns exist, that means all combinations of AB exist, and that is why all complemented and uncomplemented literals, they will cancel each other. So, it will be simply the third column. Now, the first couple, see if I take this one as the first couple, then it will be reduces to, because A bar B is that is common for the both the min terms for both ones, or and these two adjacent ones, that C is common and D bar will cancel. So, A bar B C, or no. So, this will be not A bar B C, this will be A bar B, and actually here this is the couple, this one and this one. So, for these two adjacent, D bar is common, A bar B D bar. Now, for the second couple means second couple is this one. So, for the second couple, that row is A B bar, that will be there, because both the adjacent one, they exist in the same row, and for the two adjacent column, see that C and C bar varies, that means they will cancel and it will be D. So, these are the C D, A bar B D bar, A B bar D. So, now, see this is my reduced function, that f equal to C D plus A bar B D bar plus A B bar D. So, this is my reduced function. Now, we read another things, that is called the prime implicants. Now, when a K map is plotted, all possible largest groups are circled, that already we have mentioned in the rule. Now, these groups contains 1, 2, 4, 8 or 16 mutually adjacent ones for a 4 variable function. Now, the term that represents each group is called a prime implicant. So, just now the example we have seen there, these are the prime implicants, because for this quad C D is the reduced min term, then for one couple, that the A bar B D bar is the reduced min term, and for another couple this is the min term. So, these terms, the 3 terms, they represents each group, 2 couples and 1 quad. So, they are called the prime implicant. Now, what we will see or what we will notice, that not all prime implicants are necessary in the final expression. as certain prime implicants include ones that have already been included in other PI, because we have identified all the groups, whether it is a couple or quad, or for larger variables whether it is a octuplet. Now, there exist some ones which actually is included in a couple, or it may included, the same one may included in a quad. So, then what will happen, that one or the contribution of one is actually twice, it is in one quad only or it is in one couple also. So, the third point is that not all prime implicants are necessary. Now, we will see that method, so that it can be reduced further. Now, again we take one 4 variable function. Now, see that this 4 variable function, given that f, that there are 7 minterms. So, 1, 2, 3, 4, 5, 6, 7 minterms. Now, we see that what are the minterms? See that ABCD, this is one minterm. So, I am giving that as if this is my first minterm 1. AB bar CD, this is my second minterm. AB bar C bar D, this is my third minterm. Then AB bar CD, again it has come because already it is there. So, AB bar C bar D, take this one as AB bar C bar D. Okay. So, this is my fourth minterm. Okay. Now, A bar B C bar D bar, fifth minterm. So, A bar B C bar D bar, A bar B C bar, this is A bar B, okay, this one is A bar B C bar D bar, or this will be A bar B C D, okay, just we put so this will be A bar B C bar D bar, okay, A bar B bar C bar D bar. So, this is my 1, 2, 3, 4, this is my fifth minterm. Okay. Then sixth is A bar B bar C D, this is my sixth one, and seventh one is A bar B C D bar. Seventh one is A bar B C D bar. Okay. So, this will be my seventh one. So, I am putting this as 0, this as 0. So, now what will be the prime implicants? See, if I take this as the, okay, if I want to form a group or a quad group, then I am taking this is A bar B bar C D bar. Okay. So, I am putting A bar B bar C D bar. Okay. I am taking these as the 0. This I am taking 0. This is my seventh minterm. Now, see that for these the prime implicants are, see, one is the first, this is one quad, this is one quad. So, for this the prime implicant is, if I write the prime implicants, so for the one is that A bar, B bar, because that this is nothing but the first row. Now, similarly, if I group, say this is one, this is one, see another quad can be there. So, if I take, see this can be a, if I fold, this can be another quad. Now, for this quad, what will be the min terms or what will be the reduced term from the K-map? See that for the two adjacent, these are in two adjacent columns, C bar D and C D. So, D is common. So, I put D. Now, they are in the first row and the fourth row. So, in between first row and fourth row, B bar is common and A bar will cancel. So, this will be B bar. So, another prime implicant will be B bar D. Now, see another one is left. So, I have to form another, this is another couple I can do. So, this is one couple. So, for these two couple, as they are in the same column, so C D must be there and A must be there. So, A C D. So, these will be A C D. So, this is for my quad 1, this is for my quad 1, this is for my quad 2 and this is for my couple 1, one couple exists. So, these are all, these three are the prime implicants. So, these are some example of the prime implicants. Now, if I take another example, then these where the prime implicants are, say that the previous page we have seen that if I take one example where the prime implicants are, these are the prime implicants, that A dash B, B dash D, A dash C D, D dash, B C D dash, A C D, A B dash D and A B C. So, these are the prime implicants. Now, if we reduce these terms, then what will happen? So, if I take this example where we see that how many quads, and this is one quad. Okay. Now, say this is one quad, this is one quad. Now, what we can do, there can be many couples. See, here we can take these two as the couple, because this one is left. We can take this one is the couple and we can take this one is the another couple. Now, see, if I take this particular example, then this A dash B, or actually this is A dash B dash, A dash B dash is the for the first quad. Then this is for the C dash D and CD, that means D and B dash. So, for this quad it is B dash D. For this quad that folded or wrap around, this is B dash D. Now, which one is A dash C dash? A dash CD dash. See, CD dash means the last column, and A dash is fixed, that means for this couple this is A dash D CD dash. Now, B CD dash, CD dash means again the last column, and see the second row and the third row, the B is common. So, this is the couple, this is the couple, this couple, for this couple it is BC dash. Then ACD, ACD means which one? A is, this must be the third row and fourth row. So, and CD is the, so another couple is there, this is another couple, ACD. Now, AB dash D, AB dash D, which is one? AB dash D is the, AB dash is the fourth row, and D is this one, that means here another couple can be formed, and another is ABC. So, ABC means this is my AB, and C means, so this one is the couple. Now, see, that means here for this particular example there are 2 quads and 5 couples exist. Now, as already we have seen that there are many ones that are already or that are included in more than one group, that can be a quad or that can be a couple. So, there can be many redundant things. So, all these are prime implicants because they represent one group. Now, only we will keep which are, these are not all necessary for the function, because there are many are redundant, that one exists in more than one group. So, these are not all necessary. So, now how we can reduce that thing? So, this from these 7 terms, all redundant implicants must be eliminated. Now, how we can eliminate these redundant terms? Again we see that thing, that means now what we will be doing, that if I already consider 1 and if that forms a quad or couple, then I will not consider again unless its adjacent one exists there. What does it mean? See that again for this particular example, say now again we will regroup that thing. Now, see I have, okay, this is one, simply this is one quad, this is one quad. For this quad, this is the term A dash B dash. Now, I will form this quad, which one? That wrap around fashion, because always this can be a couple, but if possible I will always find out the largest possible group. So, that is why I will not take the couple, rather I will take the quad. Now, these two, they will reduces to, they will reduces this quad, they reduces to the b bar d. So, this is the b bar d. Now, see that earlier there are many couples we consider, but now I will not consider these couples. See, only 3 ones are left. So, what I can easily do? I can form, because these ones are already considered. So, I will not take this as a couple, rather I will take this one as a couple, and I have to take either this one or this one, because this one, for this one, this is actually I have to take, because otherwise this one is left, it will not be grouped. So, either I can take this one or either I can take this one. So, for this one, this couple it will be AB, ABC. So, this for this couple it will be ABC, and if I take these as the couple, then it will be CD bar and B. So, this will be BCD bar. So, this will be BCD bar. So, which one I will be taking? We are taking this one as one, this one, this is, and this. Now, we see that, see, this is A bar, B bar, B bar D, ABC and BCD bar. So, these are reduced to. So, elimination of all, actually we have eliminated some of the implicants. Only we have considered 4 prime implicants out of these 7. So, 3 are redundant. So, normally we follow this rule, otherwise this is always this explores. Now, there are some disadvantage of these. So far we have discussed that K-map method. See, if it is for larger variable, what we have seen that for n variable functions, the number of minterms will be 2 to the power n. So, say for 4 variable functions, the map becomes 4 by 4 table. If it is a 5 variable function, then it will be 2 to the power 5, means this will be 32. So, what we have to do? That this will be 4 by 8, either I can make, or 8 by 4, either I have to give 4 rows and 8 columns, or 8 rows and 4 columns. So, that the map contains 32 elements. Now, as the variable increases, the 2 to the power n, the number of minterms will also increases, and the size of the map or size of the K-map table will also increase. Now, if I want to reduce that thing, or automatically, or by we can write some computer program, then graphically it will be very tough for, say, 10 such 10 variables, because for 10 variables e to the power 2 to the power 10, then it will be 1024 is the number of minterms, and we have to, that size of the tables will be such that some m by n, m rows and n columns, then it will be m by n. So, just what we are telling, if the variable increases, or the number of variables, if the number of variable increases, then the number of minterms or total number of minterms that is 2 to the power n will also increase. that means which implies that the size of K-map table will also increase. Now, say if we take one example that if say number of variables n equal to 10, then we have to that 2 to the power n is 2 to the power 10 and it will be 1024. So, my size of the K-map table, if it is a m by n, then this m into n equal to that should be 1024. Now, see, just now we have seen one 4 variable example, and where for this 4 variable example we have seen that there can be 7 groups. If I consider all the coords and couples, these are 7. Now, if it is a larger variable function, then the number of prime implicants will be more, or if we consider all the coords, couples, octuplet, or for larger variables that hex box or the box containing 32 ones, 64 ones, then it will be the number of possibilities of grouping will be more, and then it will be almost impossible, or even if it is possible, it will be very slow to do that reduction by graphically. And then we have to reduce also, just now the way we have told that redundant prime implicants. So, now there are several other methods exist that again all are the basic concept is the K-map, but improvement of that thing. This class will discuss another one such improvements of the K-maps, but there exist many others, and actually all that K-map is the basics, and that is why we will not discuss that all. Now, one very important and very popular technique is the Quine-McCloskey. So, the rule is the eliminate as many terms as possible using logical adjacencies. The resulting terms will be prime implicants. So, mainly the K-map, the reduction principle is to notice the adjacencies, because grouping is done by the adjacencies. So, here we are eliminating this term by using or by noticing only the mean terms. We will see later the example. And the next what we have to do, select the appropriate prime implicants to minimize the final expressions. Now, see how we are doing that thing. Say I have one function, that the function have that 5 mean terms. These are the mean terms, that a b c dash d, okay, a b c dash d, a b dash c dash d dash, a b dash c d dash, a dash b dash c d dash, a dash b dash c dash d dash. Now, if we do, first we are doing, we forget about all the K-maps etc., just using our theorems and postulates. Now, what it will be the thing? See, if we keep the first term as it is, because there is no common thing. Here what we are seeing, if we apply our, so we come from here, we just currently being, we forget about the result. So, this is that a b c dash d, we keep as it is, because there are many other where we can take the common terms. See, for these two, if we consider these two, see here b dash c dash d dash, b dash c d dash. So, a b dash d dash is common. So, I can take c dash plus c. Similarly, the last two main terms, I can take a dash b dash d dash, a dash b dash d dash, again this will be c plus c dash. Now, c plus c dash is 0. So, this reduces to a b c dash d plus a b dash d plus a dash b d. This is equal to a b c dash d. Again, see here, from here a and d is common. So, plus c a d, then b dash plus b. So, this can be a b c dash d plus a d. Now, from here again we can reduce that a d b c dash plus 1, that means 1, and that can be reduced to a d. So, this type of reduction is possible. Now, this is from that if we apply the theorems. Now, see we again if we check a b c dash d, a b c dash d dash. There is one mistake here. Actually, here we have taken d as the, here these two terms we have taken a b dash d dash is there, and that is why a b dash d dash, and similarly here also a dash b dash d dash. Just these are actually complemented, d dash is complemented in all the terms. So, just again if we do the same thing. So, a dash b dash d dash, a dash b dash d dash. So, from here b dash d dash will be common, this will be a dash plus a dash plus a is 0, this is b dash d dash. Actually, here d dash is complemented, all the terms d dash is complemented. So, this is a dash b, c dash d, b dash d dash. This is from my reduction using the postulates and the theorem. Now, we see if I apply the Quine-McCloskey rule. Now, see first what we are doing, we are applying the rule that we are computing number of complemented variables and the terms. See here there are 5 terms. Now, in the terms which have the complemented variables 1, see there is only one term, only one mean term a b c dash d. See here the c dash is, this c dash is complemented, c dash is complemented. So, it is 1. If the number of complemented variables are 2, I have only one mean terms where this b dash and d dash, that means 2 complemented variables are there. If the number of complemented variables are 3, then there are 2 terms a b dash, c dash, d dash, a dash, b dash, c d dash, 3. Number of complemented variables are 4, I have only one term a dash, b dash, c dash, d dash. So, these are the mean terms. Now, so these are the table. Now, I see that original terms and the reduced terms. So, number of complemented variables is only 1. So, I keep as it is because it is not reducing anything. Now, here the concept we have applied is that mainly we are seeing the logical adjacencies. See that two columns are adjacent means only one variable, in one column it will be complemented, the next column it will be uncomplemented. So, if it is a 4 variable function, then the 3 variable remains same and only one variable will vary complemented or uncomplemented for the two adjacent columns, and the same thing is true for the rows also. So, this concept we are applying here. Now, see the because we have taken the number of complemented variables are same. So, here we are a b dash c d dash plus a b dash c dash d dash. See here the a, b dash and d dash, these 3 variables are same, whereas only c varies. So, c plus c bar is 1. So, the reduced term will be a b bar d bar. Similarly, if I take the 2 this type of original terms, so all possible combinations of 2, then I will be getting these 4 such reduced terms. These are the 4 reduced terms I am getting, and this is not reduced because only one is there. Now, again we continue that with this process with the reduced terms. So, now the original terms becomes that which one was not reduced, that is as it is. So, a b c dash d. Now, from the previous table we get a b dash d dash and a dash b dash d dash. So, that means the from these 4 reduced terms, these 4 reduced terms we are considering that 2 at a time, and it is reduced to b dash d dash and this is reduced to b dash d dash. Again this 2 reduced to b dash d dash. Now, again we apply, we will be seeing because here both the terms are b dash d dash. So, that means x plus x equal to 1. So, b dash d dash equal to 1. So, it becomes a b c dash d plus b dash d dash, what we have achieved by from the table also. So, the Quinn-McCloskey we can apply for that automated reduction procedure. Now, today's quiz question, that only one question is there, that 4 variables are used to represent a 4-bit binary number. When certain numbers occur, a logical one should be generated. The numbers for which the output is 1 are 1, 4, 5, 9, 11 and 12. Assume that complemented variables are also available. So, you reduce this expression. So, the thing is that find out the expression and reduce the function. Reduce the function.